Okay, so I just wanted to make a video going through a few of the exercises on finding limits. And admittedly, as we said, as of right now, most of the ways we're going to find the limits are either by looking at the graph or by just plugging in the value that we're taking the limit at and seeing what happens. We haven't gotten to the real algebraic stuff yet, so these are pretty straightforward. And I'm not necessarily going to graph all of these. You can use Maple, a graphing calculator. You can use Desmos, whatever's available. But we're just going to go through a few of these. So on page 18, in exercises 1 through 12, evaluate the limits by using the graphs of the functions. The plot command in Maple may be used in these exercises, or again, use whatever you want. But for something like number 1, find the limit as x approaches -1 of 3x plus 4. 3x plus 4 is just obviously the equation of a line. 3x plus 4, that's an intercept of 4 and a slope of 3. So it's going to look something like that. As x approaches -1, I'm not even really going to concern myself with this. If I plugged in -1, I would get 4 minus 3, which is 1, right here. So at -1, I get 1. And then clearly, if I look at the x value, -1, as I approach -1 from the left, the function approaches that. As I approach -1 from the right, the function approaches that. So what's my limit? 1, assuming that quick math is correct, and it looks like it is. And I would point out, I've gotten emails from a few of you asking questions about the homework and all of that. Sometimes we find the limit this way by using the graph. Sometimes we find it by using the limit properties. Sometimes we find it using epsilon delta. Sometimes we find it by doing algebraic tricks. Sometimes we find it by just plugging in, which you can also do here. Ultimately, you want to be able to find the limit in as many ways as possible. That's why we're going through all these different ways, so that if you can graph the function, you can just say, oh, here's the graph, there's my limit. But sometimes you have to be more mathematical, and just looking at the graph doesn't work, and you have to say, okay, I'll find my left-hand limit, I'll find my right-hand limit, then I'll get my limit. Oh, now I have to apply the limit properties, and ultimately I want you to know all the different ways to find limits, which is why we're going through all of them. You do not have to use every possible way on every problem. Just do whatever the problem says, because they're designed to teach you all the different tricks. Okay. Let's see. Are any more of those worth doing? Something like this. Where's my eraser? My eraser fell on the floor, and oh, there it is. So suppose we have the limit as x approaches pi over 3 of tan x. We didn't really do any trig functions yet, but all you do is graph this. You can graph this, or in this case, I'm going to assume you all remember the graphs of your trig functions. We are going to use them, so it is important. Tan function, sine over cosine, y over x. It just looks like that. And that's at pi over 2. The vertical asymptote's at pi over 2. Pi over 3 is 60 degrees, so it's like right here. So clearly, the limit from the left and the right will exist, and my limit will be right there. And you can just plug it into your calculator. You should remember, hopefully, the unit circle from your trig classes. Let's see. Sine of 60 degrees is root 3 over 2. Cosine of 60 degrees is 1/2. 2's cancel, and I get root 3, and there's my limit. But again, just because it's trig or an exponential function or a logarithmic function or whatever, the assumption is you understand all of those, and then all you have to do is graph it or just plug in and get the limit. Let's see. This one right here. I'm going to keep finding my eraser. Suppose we have the limit as x approaches 5 of x squared minus 3x minus 10 all over x minus 5. And I could graph that, but rather than doing that, and again, graphing this is completely fine, But rather than doing that on this one, when we did one of these before, we said, well, if I just plug in 5 to see what's going on, 25 minus 15 minus 10, that's 0 on top, 5 minus 5, 0 on the bottom. That's undefined. So what do? And the algebraic trick we said was factor it. The top is x minus 5, x plus 2, all over x minus 5. The x minus 5's cancel, and I get x plus 2. Now if I think about the graph, it's the equation of a line, slope of 1, intercept of 2, but at 5, I have a hole. But again, clearly, at x equals 5 right here, as I approach x from the left and the right, the function will approach that value. The fact that there's a hole there and it's undefined doesn't matter. And let's see, the value would actually be 5 plus 2, 7. So the limit here will be 7. And let's see, that might be all we need to do from this section. Let's see, I want to do one that I didn't give you homework. Okay, I guess I'll do this one. Find the equation of the tangent line to the curve f of x equals the square root of 9 plus x at the point 0, 3. So, as far as the equation of the tangent line goes, we said the equation of the tangent line is y minus, and now here I have to be careful. I want to say y sub 1, because that's what I'm used to, but your book uses y sub 0, I do believe, equals m times x minus x sub 0. But this slope right here, we said, was the limit as x approaches x sub 0 of f of x times x minus x sub 0. But now I can just plug in. For this one, I have f of x equals the square root of 9 plus x at the point 0, 3. And so right here, at the point 0, 3, I can plug in, that's y minus 3 equals m times x minus 0. All I need is my m now, but my limit is the limit as x approaches, I want to find it at 0, so I need to find the limit as x approaches 0 of the square root of 9 plus x. But clearly here, I could graph this. I'm not going to. If I plug in x equal to 0, I get the square root of 9, which is 3. So I get y minus 3 equals 3 times just x. I don't need the parentheses there. These equations of tangent lines we'll actually use a lot. We'll expand on them. And to give you an idea, I'm going to be teaching Calc 3 in the fall, multivariable calculus. And when you do multivariable calculus and you have planes floating in space, like three-dimensional planes in space, you actually still do equations of tangent lines, only they're equations of tangent planes, but the principle is the exact same. Instead of having y and x, maybe you have x, y, z, and you just repeat this process multiple times. That's x, there's y, so I add on a z term right there with the same process. So these are important, the understanding of how to find these things. Good. And the last thing, I'm not going to draw this out because all of you have the graph in your book. Number 17, which I did actually give you for homework, I think, but just so we're clear. Figure 14. Why does problem 17 have figure 14? That's a little bit odd, but whatever. Figure 14 is the graph of a piecewise defined function f of x. Find the following limits. And since I gave you all of these for homework, if I remember correctly, I'll just do like the first two. A, the limit as x approaches 1 from the negative, which is the left, of f of x. So on your graph, you go to x equals 1. As you approach x from the left, clearly on the graph, from the left, the function values approach 4. The function is undefined on the left there, but it doesn't matter. From the left, as the x's approach 1, the y's approach 4. So for A, you get 4. And then for B, the limit as x approaches 1 from the positive of f of x. As you approach 1 from the right, your function values clearly approach 1. It's defined there, which again isn't required, but clearly as you approach 1 from the right, the y values approach 1. So your limit from the right, part B, is 1. And that kind of gives you C, but I'll leave that up to you. If you know your limit from the left and you know your limit from the right, how do you actually get the limit of the function? Okay, that should give you a good idea of how to solve all the problems from section 1. I'm going to make another video right now covering more limits from section 2. And again, I would point out, these do seem rather trivial at this point. Look at a graph, and I actually drew some arrows out so we could see it. You really don't need to do that. You can just look at the graph, find your limit, and be done. Even as these things get more and more advanced, and they will, that trick will still work. We're going over all the different tricks so we can fully understand limits, and you can always graph the function and say, what's my limit? It's just that sometimes the graph doesn't necessarily help, or maybe you don't have Maple or a graphing calculator or Desmos available, and it's something you don't really want to graph by hand or don't know how to graph by hand, which is why we learn other tricks. But all these basic tricks are still useful and help you solve the problems out. That's why we're going over them.